Today we'll go through how to make a MultiSensor for your smart home. Let's look at the end result first. Then we'll talk about what are required and alternatives. This is my 3D printed enclosure to hold all internal components. We'll be using a DHT22 sensor for temperature and humidity, a PIR sensor to detect motion, a LDR to sense light, a MQ135 sensor for air quality, and a reach sensor to detect window open-close status. Then we have a IR LED to emulate a remote, relay module to control 2 plug sockets, and a buzzer that I'm using in case air quality is in danger zone. What's required? For components, apart from what we have mentioned, we also need a NodeMCU controller and a converter to power this system. You will also need some other simple components like a couple of resistors and transistors. This is the part that I'm dreading. For the full system, ideally you do need a soldering iron and some basic skills to solder joints. Don't despair though. You can create most of the system without soldering. You will just miss 2 plug sockets, light sensor, IR remote emulator, and a visual indicator. In that case, you will be using DuPont female-to-female cables. For the enclosure, I designed and printed out this enclosure with my 3D printer. To be honest, if you look around, you will find many alternatives. My final enclosure is just a bit bigger than a box of cigarettes. So now you know what's needed, let's jump into the circuit view first. Don't worry about this scary looking part. It's this relay module and I couldn't find a better part design. In heart of our circuit is this NodeMCU ESP8266 controller. This has a built-in Wi-Fi controller, one analog input and a bunch of digital I/O, and we would be using most of them. First, powering this device, I'm using this HLK PM01. It will take in 220 volt AC and give me a 5 volt output. This is important, so please keep it in mind. Only NodeMCU and the relay module takes this 5 volt. The remaining components will be using 3.3 volt and that would be coming from NodeMCU. Positive output will be going to voltage in pin. Ground output is obviously connected to ground pin. One thing you need to decide here. Full system has 6 junctions that would need 3.3 volt rail. Non-solder version would only need 3 junctions. That works out fine as NodeMCU has 3 pins with 3.3 volt. So you can use DuPont for a straight connect. Otherwise, you will need to figure out your cable management. In my case, I hooked up all components on this top part with one cable passing this 3.3 volt and brought that cable to NodeMCU. MQ135 has 4 pins. We will use 3 of them. V-in is connected to plus 3.3 volt rail we have just mentioned. We have ground and A0 or analog output is connected to NodeMCU A0 analog pin. DHT22 with 3 pins, V-in to plus 3.3 volt rail, and data pin connected to D0 in NodeMCU. PIR sensor is also powered by 3.3 volt. Data pin is connected to D7 in NodeMCU. Read switch is connected to ground and the other end to D6. Quick refresher. When a magnet is brought close to this read switch, it turns on and passes ground or 0. In my case, when I open my window, the magnet moves away and that turns the switch off. Buzzer is also connected to ground and the other end to D4. That was all the part that can be hooked up without soldering. Now let's start with the LDR, light dependent resistor. The idea is, as more light shines on this sensor, its resistance drops. Without any light, the ones I have gets to around 10 megaohms. This is an analog sensor, and as our NodeMCU has only one analog pin, we have to use a variable resistor to create a voltage divider to treat this LDR analog as a digital and passing that to D1. If you're not using the air quality sensor, you can take off the variable resistor and connect the LDR straight to A0 input. I'm using a small green LED as visual indicator going to D4 that would blink depending on current state. As both this and the IR LED runs on a lower voltage, I have used a 1K resistor just to be safe. For the next two components, I have used a generic NPN transistor only as a driver. There will be some more information about this later on and how it might be possible for you to skip it. IR driver is hooked to pin D5. For this HL52S relay module, I have two drivers that are connected to pin D2 and D3. Without getting into the details why, you will need to pass it both 5V and 3.3V. This particular jumper needs to be removed. Note, plus 3.3V goes to VCC and 5V goes to JD VCC. You can use either ground post for ground. A quick look through the actual code running on NodeMCU is pretty simple. I have a setup to set which parts of the sensor to use. So if you decide to use the non-soldered version, you just set use power LED, use relays, use LDR, and use IR to false. I have written it to broadcast values using MQTT with auto discovery. I have a previous video showing how MQTT works with HomeAssistant, and I have linked it in the description below. Here I have all the topics it would be using. As I have several of these multi-sensors scattered around my house, I'm using a variable that will get replaced in code with the actual device name, followed by all the pins we have used. Obviously, we don't want to poll all the sensors all the time. For some, we should poll more frequently than others. I have set up a simple scheduler that would poll based on my settings. The code also supports over-the-air programming or OTA, which means I can update my code, compile, and upload it to my local web server. Then I can send a command to this multi-sensor, which would then update itself with the new firmware. Currently, this code is not available on GitHub. If there is any request, I'll be happy to upload it. Finally, I would like to talk about the transistor drivers. There's a limit on how much current a NodeMCU can output. On a different project to control my house heater, I have a NodeMCU connected to only one relay and a buzzer. In that case, it had enough power to drive the relays without using the transistor driver. But in this circuit, it's not the case. To make matters worse, this relays can lit up indicating it's on, but the coil itself wouldn't get energized and switch on. You will know this as the relay has an audible sound when it switches on or off. With a simple transistor driver, I know it will have enough current. That's all for this video. If you need any help or have any questions, please ask and I would be glad to help. Happy home automation! As you might have noticed that this is quite a new channel, and during this genesis, comments and subscribe counts a lot more than usual. So if you have enjoyed this content, please drop a comment and like the video, and maybe subscribe as well. Also check out some of my other videos. Thank you.